All right. Solving triangles.
Yeah.
This is actually not as hard. Well, it depends. Draw a picture, always. And angle A is 45. Angle B is 42. What's that make angle C?
We don't know.
Well, actually we do. In other words, if you know two angles of a triangle, you know all three. What's the third?
Yes,
What's the third?
Yeah,
180 minus 187. So that, I believe, is 93.
Yeah.
Okay. And now they say that side B is 74. So really they've given us three pieces of information. We were able to calculate the third angle, but really all of these problems are the same. They give you three pieces of information.
Yeah.
And we need to solve for little c and little a using the law of sines. So, the law of sines basically says that the sine of any angle of a triangle divided by its opposite side is a constant within that triangle. In other words, it's also equal to the sine of any other angle divided by its opposite side.
Yeah.
In other words, that's the law of sines. And the only thing you need to apply the law of sines is one angle and its opposite side. You have to have at least that. And in this case, we had that. In fact, let me erase this 93 just so it doesn't get confused. And let's just apply the law of sines here. Well, the only relationship we have is the sine of 45 sine of 42 opposite 74. So that is a constant. Now, the other angles we have, so that has to be equal to the sine of 45 opposite little a. Well, only one unknown in that equation, which is little a. And so I can solve for little a.
Oh. Wait, wouldn't that be sine of 45 over 74? Equals sine of 42, right?
No. The fundamental relationship is the sine of an angle divided by its opposite side. Well, that's what that is the sine of 42 divided by 74. That's what's constant in this triangle. And if it's equal to this, then A must be equal, just doing a little algebra, times 74. Hold on a second. Let me write this better. A equals, by cross multiplying, and then dividing by sine of 42, I get that. Well, what's that number in your calculator?
What's that? 74 sine 45.
Sine of 45.
Divided by sine of negative 68.7.
What kind of calculator are you using?
GMAT.
Okay, you in radians or degrees?
I am hold on a second.
I guarantee you you're in radians.
I am.
You need to be in degrees. And notice that a cannot be a negative number. A has to be a positive number, little a.
Yeah.
So if you do this problem and you come up with a negative number like you did, that tells you you got it in the opposite of what you need it in. You need it in degrees.
So should that be a positive number?
No, it's not just turning it into a positive number. When you switch from radians to degrees, it changes everything. You can't count on anything being correct. If you're in radians and you need to be in degrees, you got to switch it to degrees. Do you know how to switch the Inspire to degrees?
Yeah, I do.
Okay, go ahead and do it. Yeah, there's no simple conversion between the two. If you got it in the wrong one, you're not getting the right answer.
Trying to mess with my calculator just a little bit.
It's not that easy to switch from degrees to radians. That's the only thing about the Inspire that amazes me. It is a fabulous instrument, but they make it awfully tough to switch between degrees and radians. You got to go through documents.
Yeah, there we go. 78.199.
78.199. Now, let's look at that. Does that make sense? Well, it does in a sense that the side opposite the 45-degree angle has to be longer than the side opposite the 42-degree angle. By definition. Okay? So now we have two angles and two sides, but you can always solve for the third angle by just subtracting the other two from 180. So we still need side C. What's the equation for side C? And I can base it on that original relationship. In other words, that thing is a constant in this triangle. So that has to be equal to what in terms of capital C and little c?
In relation to little c?
There's only one variable we haven't solved for, little c.
Yeah.
We need an equation that has little c in it. I still have this sine of 42 over 74. I can use that relationship. Oh, what's that equal to?
Sine of
capital C over little c. And capital C is 93 degrees. Little c is that. Again, I only have one variable. C has to be equal to 74 sine of 93 divided by sine of 42. Come up with that number, and that's little c, and we've solved the triangle.
Okay. 1 6.
I didn't hear it. What?
110.44.
And that makes sense. That is supposed to be the longest side of this triangle because it's opposite the biggest angle.
Oh, yeah.
Okay. Now, let's just, before we go on, let's make sure you understand this concept here. It's not the angle versus the opposite side that is the fixed constant. It's the sine of the angle divided by the opposite side. So, in this triangle here, I know the sine of 45 divided by 78.2 has to equal the sine of 42 divided by 74, And that has to equal the sine of 93 divided by 110. All of those have to be true. That is the law of sines. That's what the law of sines says. It doesn't say the angle versus the opposite side. It says the sine of the angle versus the opposite side. Okay? All right. Should we do the next one?
Yeah.
Okay. Again, they don't mix it up much, which is unfortunate because there are some tough ones.
Yeah.
This is not one of them. In other words, whenever they give you two angles, it's not going to be tough because they're really giving you 4 pieces of information, right? They only gave us 3 pieces of information, but whenever they give you 2 angles, they're telling you how to solve for the third angle. The third angle is 78. So, give me a bunch of relationships that allow, I got to solve for little c and little a.
Let's see.
Using the law of sines.
Sine. Sine of 56 over a equals sine of 46 over 70.
We'll stop there for a second. Stop there for a second. First of all, when you're doing this, always pick out the things that you know. You know that and that, right?
Yeah.
So let's start there. Don't start from this left side where there's a variable. Start there. 46 over 70. That's what we know. That's equal to the sine of 56 over little a. But let's back up a minute. Notice that it's kind of hard to solve for little a here. I mean, we got to cross multiply, and then we got to divide both sides by sine of 46. So these things work in reverse. That's what I meant to say. And by that, I mean the following. You don't have to put your unknown in the denominator. I can have a over the sine of 56 equals 70 over the sine of 46. You see what I did? It's just I'm switching numerators and denominators with both. Now, the reason that's an advantage is because now I only have to do one thing. I don't have to cross multiply. A is 70 times the sine of 56 divided by the sine of 46. So having your numerator, or excuse me, your variable in the numerator saves you a step. And these work both ways. In other words, the sine of an angle versus its opposite side, or its opposite side over the sine of the angle. I can do it that way or that way, either one. If the variable you're solving for is the side, then you want to do it this way because that variable stays in the numerator and makes it one step easier to solve for. So I don't want to write that. Really don't even want to write that. I want to write it like this. I always want to start my left side of the equation with the opposite side divided by the sine of the angle. That's the way I want to start the problem. And that has to equal to a over sine of 56. Now let me erase everything else here. Now solve for a.
Solve for a equals 70 sine 56.
I didn't quite hear that.
Over sine 46.
Hold on. First of all, I have a little audio problems. The one problem with using a speakerphone is the audio is not as good. It's harder for me to hear. So, what did A end up being? It's a number.
Oh, you want me to put A in?
I want you to solve that top equation for A.
Oh, so A equals 70 sine 56.
75.56?
No, I said 70 sine 56.
Okay, give me a number. Sine 56, you got to get out of your calculator.
58.03.
Now, you did the whole thing? That's what A is?
No, that's just the top part.
I don't care what the top part is. Just give me A. Do that whole thing in your calculator.
Okay.
In other words, the problem is to solve this triangle. The only thing I need to solve the triangle are little a and little c.
Alright. 80.67.
80.67. Okay. And that makes sense from the perspective that it has to be greater than 70 because it's opposite a bigger angle. Okay. Now, I don't need to go back and start from scratch. I can use that same relationship, 70 over sine of 46, to solve for C.
Okay.
What's the right side going to be?
The right side. Wait, what do you mean? I'm sorry.
Okay, I've got 70 divided by the sine of 46. That's one relationship that holds true for every side and every angle in this triangle only.
Yeah.
The only thing I still have to solve for is little c. So where does it go on the right side of this equation?
It goes on the bottom.
No, it goes on the top.
It goes on the top.
The top is where the sides are. The angles are on the bottom, so it's got to go on the top.
Yeah.
Now, I could have chosen to reverse it. I didn't have to have the side on the top and the angle on the bottom. I could have done it the other way, but that would have been harder to come up with C. Notice that the only thing I have to do to solve for C is multiply both sides by the sine of 78. Then I have 70 times the sine of 78 divided by the sine of 46. That's one calculation only to solve for C. That's what I'm trying to say is that's the advantage of having what you're trying to solve for in the numerator as opposed to the denominator. If it's in the denominator, it's slightly harder to solve for.
True.
That number should be bigger than 80. What is it?
Yes, it is 95.18.
Okay. Now we've solved that triangle. All right. Is that the only two problems on that page?
Yes, for that picture, I have more from...
Here's another page you sent. Let me open it up. Okay. Where do we want to start here?
Like 1, 2, 3, 5.
Okay. We'll start with 1. Surprisingly, I think I know how to do 1. And I say surprisingly because it's a permutation combination type problem. I don't always know how to do those, but this one I happen to. So, if there were no repeats, then it would just be the number of different letters. In other words, if I said, how many ways could you rearrange the letters boat? It would be 4 factorial.
Yeah.
Because I can put any of the 4 in the first position, and then I can put any of the other 3 in the second, any of the remaining 2 in the third, and then the last one goes there. That means it's 4 times 3 times 2 times 1, which is 4 factorial. But if I have a word that has duplicate letters, then it's the number of different letters. What do we have? We have a C, an A, an L, a B, an O, an S, and an E. So that's 3, 4, 5, 6, 7. So it would normally be 7 factorial if there were no duplicate letters. But there are 2. There's 2 A's and there's 2 O's. So you have to put those in the bottom like that. If there were 3 O's, it'd be a 3 factorial in the bottom.
Oh, that's simple.
Well, yeah, it is. You don't get a lot of questions like this. I just happen to remember where I had one, and that's the answer is the number of letters factorial divided by the number of duplicates, essentially. So whatever that number is, you can get. Do you know how to do factorial in your calculator? Not that you really need to.
Yeah, I do.
Okay.
I have 12, now it's 1,250.
Okay. I believe that. I'm not going to check it, but all right. What's the next one you want to do?
I had 2.
Okay. All right. This is a, what's the master equation here?
D is dirt.
Uh-huh. One of the beauties ran for the exit but arrived 2 minutes late. If she ran Y yards, that's D, in M minutes, that's T, how fast should she have run to arrive at the exit on time? So, and incidentally, our answer is going to be in terms of Y and M. It's not going to be a number. They didn't tell us how many yards she ran or in how many minutes. They just gave variables.
Yeah.
Okay? So, she ran it in 2 minutes late. So, she needs to run it, instead of in M minutes, she needs to run it in M minus 2 minutes. Then she won't be late, right? How fast should she have run? Y divided by M minus 2. You have answers on that?
That is correct.
Okay. That's actually fairly easy and straightforward. I wanted to make sure I was doing it correctly.
Oh, that's very easy.
Yeah, it actually is. In other words, the only thing you have to realize is that if she was 2 minutes late the first time, she needed to run it in 2 minutes faster. Right? Then she wouldn't be late. If you're 4 minutes late for a job interview, then you needed to be 4 minutes faster. So we need to be M minus 2 minutes needs to be our time. And then you just do a little algebra and you get what R needs to be.
Oh.
Okay?
That one's simple.
Yep. What else we got, Justin?
Yeah, number 3
Okay.
and 5.
Ooh, 3. Boy, they just keep repeating every type problem with different numbers and different strategy.
Oh yeah, and they always start with the first, they always start the problem sets with the first 5 or 6 problems as word problems.
Yeah, no, I know. But every paper you've sent me basically been the same. In other words, we have a permutation or a combination problem, and then we have a dirt problem, and then we have a work problem. And then we're going to have a probability problem. And then we're going to have whatever. But they give you the same sequence, just different problems. So let's figure out this one. He pays M men Z marks for W weeks of work. Usually the best way to solve these kind of problems, if you're having difficulty with them, is to make up letters, make up numbers for the letters that he's giving you. That'll usually make it a lot easier. Okay, so let's try that.
I have a question. Is this an RTW problem?
Is this a what?
Is this an RTW problem? Like, our teacher taught us, he said, like, the base equation for one of, I don't know if this is one of the problems, but like one of the problems was RTW equals J or jobs. Like that.
Not familiar with that. Not familiar with that. So it might be. I just am not familiar with it. Here's what I'm going to do to solve this, to see if I can solve it. Make M2. Let's make Z 10. And let's make W3.
Okay.
Make up numbers that are different from one another. Okay, so what this says is that he pays 2 men 10 marks for 3 weeks of work. So let's translate that. He pays 2 men 10 marks to do 3 weeks of work. How many men can he hire for 1 week if he only has 1,000 marks? Let me think for a minute. How many men can he hire for 1 week? All right, so let's go back and look at our original thing. If he pays 2 men 10 marks for 3 weeks of work, how much would he have to pay those 2 men for 1 week of work?
Half that.
Okay, so
5 marks.
No, but we need an M that is a multiple of 3. So I'm going to make M 6. So he's going to pay 6 men 10 marks for 3 weeks of work. And let's make the 10 a multiple of 3, so we'll make it 12 marks. You'll understand why in a minute.
Okay.
So if you pay 6 men 12 marks for 3 weeks of work, how many men could be hired for 1 week?
2.
Right. So that's the same as saying you would pay 2 men 12 marks, or not 12 marks, a third of 12 marks, 4 marks for 1 week of work. Correct?
Yep.
work, not week. Okay? So, how many men can he hire for 1 week if he only has 1,000 marks? Well, given my numbers that I've plugged in, how many? How many men could you hire for 1 week if you had 1,000 marks?
500.
Yeah, exactly. So you could pay 500 men, and you'd have to multiply this by 250. So you'd pay them 1,000 marks for 1 week of work.
Yeah.
So the answer is 500. The problem is that that's only the answer given the numbers that I've plugged in here. In other words, we need the equation. In other words, 1,000 equals number of men the number of men hold on a second. These are always super tough. But
Yeah.
we can do it. Just a second. Let's see. I got to think of how we're going to do it here. So what's the equation that allowed us to come up with these numbers, 500? Well, I started with 2, right? I ended up multiplying it. No, I started with okay. So M divided by W gave me how many men I could hire in 1 week, right? In other words, I started with an M of 6 and a W of 3. I just divided that to come up with, well, that means I could pay 2 men for 1 week of work. But I would only have to pay them not 2 marks, or not 12 marks, but only 4 marks. So I wouldn't have to pay them Z, I would have to pay them Z divided by 3, W.
Yeah.
So let's see, does that work? So I had 6 divided by 3 times 12 divided by 3. That gave me 2 times 4, and that has to equal to my Z. 1,000 divided by Z. Let's see, 1,000 divided not by Z, but by Z divided by W. In other words, that gave me 12 divided by 3. So I had to divide my 1,000 by this Z divided by W. That's what I've done there. I've divided 1,000 divided by 4, which is 250. I got lost. This problem is so hard that I got lost. You can kind of see what I'm doing. These are so tough, especially when they don't continue the variables. In other words, when they substitute a number in there. Let me think for a moment. Let me start again here. Not that I want to use our entire session on one problem. I always hate that, especially when it's because I don't know how to do it. But, so, let's see. The amount you have to pay is the number of men times the number of marks, times, this is a work problem just like all work problems. That's where we start. Remember what I said on how to solve work problems? Is you bring it down to a unit number. In other words, if I pay 6 men 12 marks for 3 weeks of work, then I got to pay 6 men 4 marks for 1 week of work. So each man makes 4 divided by 6 marks per week of work. I think that is a true statement based on the numbers that I have used. And the way I get this is 12 divided by 3 divided by 6. So it's Z divided by W divided by M. That's how much each man makes per week. That's the pay that each man makes per week. Z over W over M, which comes down to Z over WM. It's the same thing. And now the question is, how many men can you get for 1,000 marks for 1 week? Well, if each man makes 4/6 of a mark per week, well, then you can get well over 1,000. And in fact, how many do you get? You get 6 over 4. No, you get 1,000 divided by 4 over 6. If you're paying every man 4/6 of a mark per week, and you got 1,000 marks to spend, then that's how much work, that's how many men you can hire.
Exactly.
And that, relative to our numbers, is 1,000. I'm going to write in red. So it's 1,000 divided by 4, which was Z over W, divided by M. So there's the answer, and that ends up being WM over 1,000Z when you do the algebra. So now, if your life depended on this question, you'd want to check it, right?
Yeah.
Well, what did we figure out? We figured out that with these 3 numbers, the answer has to be 500 men.
Wait, why would 1,000 be on the bottom there? Because don't you just multiply by the reciprocal, so 1,000 is still on the top.
You're right. Very good. Thank you. Good catch. So that, yeah, no, thank you. I would have discovered it, I think, as soon as I plugged in these numbers. Yeah, and that's going to work because W times M WM over Z has to end up being a half.
Yeah.
And it's not. WM is 18 divided by Z is 12. That ends up being 1.5.
Okay.
I'm on the right track.
Yeah.
But we've already spent 15 minutes on this problem. Don't really want to go back and start from scratch and spend another 15 minutes on it. But this is definitely a way you can solve it. I'm not sure it's the proper way to solve it. Kind of like solving it in terms of variables like this method over here, and breaking it down to how much X amount of marks, that'll get you one man for 1 week.
Yeah.
So if I had 1,000 marks, I should be able to divide it by 4 over 6 and get how many men I could get. Now, I may have a mistake in this math over here on the left. I came up with 500 men, but I could have done the math wrong. There's so many parts to this problem that's why I don't really want to go back and redo it. We'll spend another 15 minutes on it.
I think we got the,
we got the essence of it right, and here's the thing to learn from this problem. You can always pick numbers. In other words, when they give you a problem that has nothing but variables in it, and they don't tell you what the variables are, they just give you conditions, well, you know your answer has to come up in terms of m, z, and w. Has to be a function of m, z, and w. And whenever that's the case, you can pick numbers. And the advantage of picking numbers is you can usually figure out what the answer has to be with the numbers you picked. In other words, by picking 6, 12, just 6 and 12, I was able to figure out a lot of things. Or 6, 12, and 3, I was able to figure out how much you would pay for 1 week of work for one man. And then once you get that, it's a question of working it back through to get your answer to be 1,000 times that. Oh. So I came up with you'd pay 500 men 1,000 marks for 1 week of work. So 500 needs to be the answer, assuming I did this math properly. But again, I don't want to waste any more time on this. Sometimes these problems are just so hard that it's not worth spending the whole hour trying to solve that problem.
Yeah.
If we had an unlimited amount of time and I was a little more on the ball here, we could do that one. But let's go on.
Okay. All right.
Number 4.
I got 4.
Okay.
You get 5.
Yeah. All right. This is actually a pretty simple word problem.
Good. Just help me understand it.
Yeah. It's a 3-digit number. Okay? Let's call that number ABC. That's a 3-digit number.
Okay.
Now, the sum of the last 2 digits is 7. So B plus C equals 7. The sum of the first 2 digits is 5. A plus B equals 5.
Yeah.
The middle digit is 4 times the first digit. That's B equals 4A. What's the number? 3 equations, 3 unknowns. Let's go through this solution. Because the way they're giving you these aren't that hard. Usually 3 equations and 3 unknowns can be trying at best. But let's just use substitution. Substitute B into, here's our equations, 1, 2, and 3. Substitute B in for equation 2, and we'll have an answer for A.
So 5b equals 5. A equals...
A plus 4A equals 5. So 5A equals 5. So A equals 1. What's B equal to?
B is equal to 4 times A.
What's C equal to?
B is 4.
What's C equal to?
D is
C.
B plus...
C.
Okay, so C equals 7. 4 plus C equals 7. C equals 3.
There you go.
Oh, that's actually quite simple.
Yeah, it is. As long as you end up with 3 equations where you can use substitution, which I could, because the bottom equation is completely solved for B. So I'm just going to substitute 4A for B in the above equation. That leaves one equation, one unknown, so I can solve for A. Once I solve for A, now I got B. Once I got B, I got C. The trick on this problem is probably that part right there, is to write the number as 3 variables. Whoops.
Yeah, that's actually much more simple than I thought it would be.
Okay, how about number 6?
Yep, I know how to do those.
Okay. What's the next one?
7 and 8.
7 and 8, okay. Hold on, let me get... Why am I having problems moving that up? Because... can't do that. Hold on a second. Don't tell me I did this one. I'm alright here. Hold on. Alright. 7 and 8. Let me get those. How come I can't move that up? Oh, your picture apparently didn't take all of 7 and 8. Notice I can't see 7 and 8.
Oh, okay. Well, then I'll read off the rest of the time.
Yeah, I was going to say, you don't need to send me another picture. Let me just redraw these 2 triangles. I can see enough of them. So we'll do one at a time here. So that one's 8. And
yeah.
M. What am I missing?
And A, M, and A at the bottom. There's the hypotenuse.
This is A?
Yes. So the top angle is A. Bottom left was 40 degrees. And the bottom right was 30 degrees.
So what's the top angle?
The top angle would be 110.
All right. So how am I going to solve this?
So sine little a over big A.
No? Remember, you're always taking the sine of an angle. You never take the sine of a side. You take the sine of an angle. So if you're going to take the sine of anything, it's going to be 110 degrees. That's big A. Divided by little a. But that's not really where you should have started. Let's go back and do these correct. Start with the one known angle and known opposite side. Start there. There's your fixed relationship. So give me that for starters, always. Doesn't matter the order. You can put the sine on top or on bottom.
Sine 30 degrees over 8 equals sine 40 degrees over m.
Okay, let's stop. Solve that. What's m equal to? What's the algebra? Don't give me a number. Tell me how I'm going to solve for m.
The algebra, m equals 8 sine 40 over sine 30.
Okay, good. Now what's that number?
1 sec. 10.28.
Okay. And now, how do you solve for little a? That's the only thing we haven't solved for, is little a. Give me the equation that solves for little a.
Hold up 1 second.
And you don't need to use a different relationship. In other words, that same sine of 30 over 8 applies to all angles and opposite sides in this triangle. So we'll just leave that there. What's it equal to?
Sine. So we have sine.
Here's the way to look at this. Justin, here's the way to look at it. Here's what you're doing. You're taking all of those pairs. Okay, then we did that pair. And finally, we got to do this pair. So what's the right side of this equation got to be if this is the pair I'm working on?
Sine 110 over little a.
All right, that's what I'm trying to get at. In other words, it's always angle versus angle divided by opposite side. Okay, and then I trust you know how to solve that, so let's go on. And look at the bottom one. Let's see. Yeah, I'm going to need, I see a triangle that looks kind of like this. With that being B and 12. That's B and that's 12. What am I missing here?
130 degrees is the big one. C is the left side.
So C, little c is the left side of the triangle.
Yes, little c is the left side.
Okay. I still only have 2 pieces of information. I got to have a third piece to solve this problem.
Little b is the bottom side, and little b is the bottom side, and 22 degrees is the bottom right.
Okay. Now, whenever they give you 2 angles, probably the thing that makes the most sense is to go ahead and put the third angle in there. That's the easiest thing to figure out next.
Yeah.
So what's supplementary to 152?
228.
Okay. Now let's apply our law of sines. The only thing we have to solve for is little c and little b. This time, make sure they're in the numerator.
Okay.
So what's the left side of my equation going to look like?
Wait, why do we have to put them in the numerator this time?
You'll see. Always, if your unknowns are in the numerator, it's one less algebra step to solve for. Let's do this one and you'll see why. I'm going to put the side in the numerator. And the only side I have is 12, but I'm going to do it this way this time. I'm going to put the side length over the sine of the opposite angle. What's that going to be equal to?
For C?
Yeah.
For V? Or?
Well, solve for either one of them. You can solve for either one of them at this point.
Well, sine little b over 22 degrees?
No. In other words, I got it reversed. I got the side over the angle. You got to keep it that way. So if I'm solving for C, the C goes in the numerator and the sine of 22 degrees goes there. Now, notice I only have to do one thing to solve for C. I don't have to cross multiply. I don't want to cross multiply. I want to just multiply top and bottom by sine of 22. So it's definitely one step easier, faster, if I make sure that my unknown is in the numerator. In other words, I could have written it like this up here on the right. I could have done it this way. Make sure you see what I'm doing here, what the difference is. But if I'm going to solve for C now, I got to cross multiply and then do a second step, divide both sides by sine of 130. Well, this is a whole lot easier over here. I just had to do one thing. I didn't have to cross multiply. I just had to multiply both sides by sine of 22.
Yeah.
Whereas over here, I got to go C times sine of 130 equals 12 times sine of 22. Then I got to divide both sides by that, so I got to do this. I got to do all kinds of algebra. Whenever I have to multiply, whenever I have to cross multiply as my first start, more steps. Notice that at a minimum, this is one extra step on the right than the left. The left gave me the same answer, 12 sine 22 over sine 130, but it took one step to get there instead of two. So that's the only, and I'm not even sure that's worth mentioning. And the only reason I do mention it is because you should understand that these go both ways. In other words, it's not just the sine of A over little a equals the sine of B over little b. It's also little a over the sine of A equals little b over the sine of B. And you can choose either one. They're equally correct. It's just that if you're solving for an A or a B, the bottom one is more efficient.
Yeah.
Just don't mix them up. Don't put the sine of A over little a equals little b over the sine of B. In other words, whichever way you do them, they have to be the same. Okay? So, how do I solve for little b?
For little b?
Yeah, give me the entire equation from start. Always start with the known pair. There are no variables in that. So you know exactly how to write the left side of the equation.
So sine 28 degrees.
That's not where you start. You start with the known pair. That's what I mean. Start there. That's your fundamental relationship in this triangle that's always going to be true, no matter which side you're solving for. So make that the left side of your equation.
Okay.
What does that become?
Sine 130 degrees over 12.
Okay. That's fine. I don't have any problem with that. Now, the rest of it, we're solving for B, right? Yeah, we solved for C already. Hold on. Yeah, okay. We're solving for B. What's the right side of this equation? Solving for little b. I'm sorry.
Solving for little b. We have b over.
You'd be mixing it up if you did it that way.
No, sine 28 degrees over b.
There you go. Now solve that however you can. In other words, it's a little more difficult to solve, at least one extra step, but that's okay. In other words, it's hard to tell in the beginning where your variable is going to be. So in a way, you could start like that. That wouldn't be a bad way to start the left side of the equation. It ensures your variables in the numerator, and then that tells you how to do the rest of it. That's got to be 12 over the sine of 130. This is actually probably the best way to do it, is to start with what you're trying to solve for in the numerator.
Yeah.
Then you can't go wrong. You'll have it in the right orientation, and you can always figure this side. I've always done these problems by starting with my known side divided by my sine of my known angle. So that's my constant, and that is a constant in this triangle. It's the same no matter which side and which angle you have. The problem with doing it that way is you don't know where your variable is going to end up. It could end up in the denominator or the numerator. And you did it that way, and you ended up with your variable in the denominator, which you can still solve for. It's just a little harder. In other words, you would have rather ended up with this. 12 over sine of 130 equals b over sine of 28. That's easier to solve for b. Yeah, a little bit at least, but not easier enough that it's worth getting confused about the problem. In other words, if you can do the problem and your variable ends up in the denominator, so what? Doesn't matter that much. Oh my goodness, we were supposed to quit at 4. Hold on a second. Yeah, good. I did not have a 4 o'clock. I'm glad. I completely lost track of the time. So we will end it with this page, and I will talk to you at our next session.
Awesome. Thank you.
All right, Justin. Bye-bye.
Bye.